Hello and welcome. We're going to talk today about limit laws. If you read the page description in Canvas about this video, you will have seen that we are going to be talking about these 4 limit laws and how they're going to help us find the limits of more complex functions. We have been learning how to find limits of simple functions. Using these limit laws will allow us to find the limits of more interesting functions. We also want to have the objective today of learning these limit laws in a way that is comfortable, more in your own words, instead of memorizing these many complex symbols. So let's take a look at these 4 limit laws to begin, and then we'll do an example of using them. The first limit law, we can call that limit law number 1, although the order doesn't really matter, is we have limit, and every limit is understood to be as x approaches a. So let's kind of subconsciously put that every time we see the symbol for limit. And in the brackets, we have f of x plus g of x. So I see this as the limit of the sum of 2 functions, and that is equal to the limit of f of x plus the limit of g of x. So I see this limit law and I think the limit of the sum is the sum of the limits. The limit of the sum of 2 functions is the sum of the limits of the 2 functions. Easiest for me, the limit of the sum is the sum of the limits. And it's the same story with the difference. We have exactly the same limit law, number 2, only now we have a subtraction instead of a plus. So I'm going to call that the limit of the difference is the difference of the limits. Limit law number 3. Here we have a product. Why don't you pause this video for a minute and see if you can come up with your own words for limit law number 3. If you did that, then maybe you came up with the limit of the product is the product of the limits. And lastly, the 4th limit law, we can say this together. The limit of the quotient is the quotient of the limits. Now, the 4th limit law, I even pointed out in the Canvas page, has a restricting qualifier. We have to say this is only true as long as that denominator limit is not equal to 0, because we are not dividing by 0. We will in the future learn how to divide by 0, but we can't do that yet until we built up our understanding of calculus. So let's take our knowledge of these limit laws and work out an example of an interesting limit. So we're going to look at the limit as x is approaching 2 of x squared minus 4 over x minus 2. So our function is a rational function. It's the ratio of 2 polynomial functions. And again, I invite you to think for a minute, pause this video, and think, which limit law am I going to use? If you chose limit law number 4, the limit of the quotient is the quotient of the limits, you chose well. Let's try this out. So we're just kind of thinking, we'll put maybe we're not sure. Let's try the limit of x squared minus 4 as x approaches 2, divided by the limit of x minus 2 as x approaches 2. So these are 2 polynomial functions. The numerator is a polynomial, the denominator is a polynomial. It's easy to evaluate these limits. I get 2 squared minus 4, which is 0, and I have 2 minus 2, which is 0. So again, I invite you to pause this video for a minute and see what we would do next. I'm hoping you're thinking about that little restriction on the 4th limit law This limit law does not apply when the denominator limit is equal to 0. As a matter of fact, if we apply this quotient rule to this limit without thinking about the restriction, we get a 0 divided by 0, which we call the indeterminate form. Indeterminate form means we can't determine what the limit is yet. So it's indeterminate. And we're going to see a lot of these types of limits. When you evaluate the limit of the function and you get 0 over 0, use that as a clue to say, oh, I can work with the original limit. Maybe I can do something algebraically to change it and see what happens. And that's exactly what we're going to do here. So we did this work to determine we can't use that fourth limit law. Let's look at just the function x squared minus 4 divided by x minus 2. That's a rational expression right now. And we've learned about simplifying rational expressions. Let's see if that numerator factors. It does. It's the difference of squares. X plus 2, x minus 2 is the factorization of the numerator. The denominator is linear. We just leave it alone. But now that we've factored the numerator, we can see that we have a common factor in the numerator and denominator. We divide that out, and we know that x squared minus 4 divided by x minus 2 is identical to x plus 2 as long as x is not equal to 2. So we have done this work to determine that the limit as x approaches 2 of x squared minus 4 over x minus 2 is identical to the limit as x approaches 2 of x plus 2, which is simply a polynomial. It's linear, so we can certainly evaluate it. That's going to equal to 2 plus 2, which is 4. So the original limit is equal to 4, and we use those limit laws to help us find that limit. You are now ready to attempt the homework for this section. Happy limits!